Okay, we're back with parallelogram problems here, and you remember question number one that took, oh, I don't know, roughly 15 minutes to solve. Jeez. All right, so let's look at number two. Solve the parallelogram perimeter formula for a half. Okay, so again, what I would recommend that you do is that you actually highlight what it is that you're working with here. So it's asking us to deal with the perimeter formula for a parallelogram. Why is that so hard to say? Which is 2 times your A plus 2 times your B. Okay, we want to solve it for a half. There's no 1/2 in this question whatsoever. In this formula, there's no 1/2. What am I going to do? Well, notice that, of course, 1/2 has a 2 in it. So really what I'm going to do is first solve for the number 2 in this little formula, boop, boop, and then I will do some mathematical trickery in order to turn that 2 into 1/2. Okay, you ready for this? Now, notice that I've got 2's in 2 different places, right? I've got a 2 attached to this A, I've got a 2 attached to this B. But if I'm going to solve for a particular variable, I only want one instance of it. I don't want it in 2 different places here. So the first thing that I'm going to do is I'm going to take and factor out this 2. There is a common factor of 2 in both of these terms, so I'm going to factor it out. It's the distributive property backwards. 2 times parentheses A plus B. Right? And remember, like the perimeter formula for a rectangle, for rectangles perimeter, you sometimes write that as 2 lengths plus 2 widths, or you can write it as 2L, parentheses L, plus W. It's the same exact thing, right? It came from just using the distributive property backwards. Okay, so remember, we said that we're going to try to solve this thing for 2. To solve it for 2, the 2 that's right there, I have to get rid of this parentheses A plus B thing. So again, think of this as just one thing, one term that's being multiplied by 2. And if it's being multiplied, to get rid of it, I am going to divide. It's being multiplied, I need to divide. So I'm going to divide both sides of this problem by A plus B, both sides. I don't know what happened to this anorexic B over here. Okay. On the left-hand side, there is absolutely nothing to simplify, so you just rewrite it. P over A plus B. Okay. On the right-hand side, the whole reason why we divided it was so that they would cancel each other out, and they definitely do. The reason why is because anything divided by itself is always the number 1. Well, except 0. 0 divided by 0 is undefined. But A plus B divided by A plus B is just understood to be 1. Okay? And then we're left with is equal to 2. Okay. Now, I'm going to show you a little trick here, and it goes like this. Let's say, for example, I have the fraction 1/2. Let me think of another fraction that's equal to a half. How about 5 over 10? Right? That would reduce down to 1/2. Okay, so this type of equation is called a proportion when you have 2 equal ratios like you do here. And there's lots of cool things that you can do with proportions. Usually, you cross multiply. Notice that when we do cross multiply this, that the cross products are equal to each other. So 1 times 10 is the same thing as 2 times 5, right? That's a key thing about proportions. But what I'm going to do is this. It's not something that you usually do with proportion, but you can do it. You can take the reciprocal of both sides. You can flip both sides. Make that 2 over 1 is equal to 10 over 5. Is 2 divided by 1 the same thing as 10 divided by 5? It is. Now this equation does not match that one, but it is still a true equation. And so that means that anytime I have a proportion, I'm totally allowed to just flip both sides. If I flip one, I just have to flip the other one. So think of this 2 over here as 2 over 1, right? And now I'm just going to take the reciprocal of both sides. I'm going to flip both sides and make this a plus b divided by p is equal to, now flip the 2 over 1 and make that 1 over 2. There you got it. I'm curious to know how many of you are actually able to do that. Now, this is not the only way to have tackled that problem. Let's see, to get 1/2 from 2, you could divide both sides by 4, right? Or multiply 1/4 on both sides. That would be another way to accomplish that. Okay, let's look at the very last question, the final question that's on here. The area of a parallelogram is 12 square root of 6 centimeters squared. If its base length is 2 square root of 3 centimeters, what is the length of its height? So maybe what we need to do, this is essentially a word problem here, is write down all of our information. The area, list out these different quantities. Our area is equal to 12 square root of 6 centimeters squared, okay? If the base length is, so we have a base length, so B is equal to 2 square root of 3 centimeters. What is the length of its height? So we're looking for height. I'll put a question mark on that one. So in order to relate those quantities, I'm going to, of course, use the area formula for a parallelogram. That's where this number would have come from. It would have come from our base length, which is what was given to us, and our unknown height length. So it's basically going to turn into a little algebra problem. I have area is equal to a base times a height. Now just fill in our gaps, fill in our variables. A is equal to 12 square root of 6 is equal to our base length, which is 2 square root of 3. And then we're going to multiply that times h. Now, I don't like the fact that there's not enough room here to work, so I'm just going to copy this. I'm going to do it further on my extra little page here. Let's copy that. Copy that. I'll put it right down here. Paste it. Look at that. That's so handy. All right, so now I have plenty of room to work on this particular problem. So here, often what I do is I try to think of a simpler problem. So same kind of problem, a similar situation, a simpler problem makes it easier for us to wrap our head around. So what if this problem was like this? 12 is equal to 2h. Definitely not what we have, but it's similar. It's set up similarly. How would I solve this? To get h, which is what we're solving for, we would have to divide both sides by 2, right? Because 2 is being multiplied times the h, and they would cancel out over here. I do the same thing over here on my original problem because I want to get h by itself, and it's being multiplied times this weird irrational number, 2 times the square root of 3. That's just a number. If I want to get rid of it, I have to divide it to the other side, just like I did over here on this simple example, okay? So I'm going to divide both sides by 2 square root of 3. Divide by 2 square root of 3. And I'm going to have this situation. I have to figure out how I'm supposed to divide these square roots. What? This is crazy. Okay. Now, in another video, I suggested that you think of these square roots kind of like their variables. And these two variables, they're not the same, right? So this would be like an x and this one would be a y. But it's separate from the 12 and the 2, which are like the coefficients out front. So I can deal with, if I had, again, a kind of a similar situation, 12x over 2y, I know that I can simplify the coefficients out front. I can divide those. So 12 divided by 2 is 6. I'm going to do the same thing. This 12 divided by 2, I would get 6 there. And now I need to think about what the square root of 6 divided by the square root of 3 is. Now, a property of square roots is this. It works with both multiplication and division, but it doesn't work with adding and subtracting. You can take a quotient, that's the division problem, of 2 square roots, and they can go inside of the same square root symbol. So this is the square root of 6 divided by 3. And then you can simplify the fraction that's on the inside of this. This is equal to the square root of 2, because 6 divided by 3 is 2. So just to show you that, I'm going to pull out the calculator, because like if ever you're doing this math and you're not quite sure, you can take the calculator, do like a little investigation and see if it actually is true. So let's pull out that calculator and we'll figure out how it is that we can format that. Look over here on the far right hand side, there's this fraction bar. So I'm going to click that. It'll format a fraction for me. And I have this square root key right underneath the square key. So I'll do square root of, it was 12 on the top, right? Was it? Now I've already forgotten. Was it? No, it was 6. It was 6. Backspace, 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 backspace. Really? Really? Okay, pull up the fraction again. It is the square root of 6 on the top, and down here on the bottom, I want the square root of 3. Okay, so I hit enter. And we look at that irrational number on the end, and what's cluing me into the fact that this is irrational is because there's this weird decimal expansion. It just keeps on going. It just keeps on going, and there's not going to be any kind of pattern to it. And also, another indication for this calculator in particular, there's not this little fraction toggle button on it either. Okay, so now we thought it simplified to square root of 2. So let's just put that in and verify that those two answers are exactly the same. And notice that they are definitely the same. Okay. All right, so coming back to our problem, this is the square root of 2 is equal to, and on the right-hand side, 2 square root of 3 divided by 2 square root of 3, that's 1. They cancel out. It's any number divided by itself. It's equal to h. And I might flip this around and make this h is equal to 6 square root of 2, and then I need to think about units here. So look at the process that I did. Okay, I'm going to actually rewrite these numbers down so I can see these units play out. Square root of 6. This was area, so it had, I want to say it was centimeters, right? Centimeters. Centimeters squared. And then the 2 square root of 3 had centimeters attached to it, and then I'm multiplying it times the h. And then what we did in the very next step is that we divided by 2 square root of 3. So again, I'll do that. 2 square root of 3. Take the units with it. Centimeters. Over here it disappears. And we already talked about how to simplify that, so don't worry about that. Instead, let's now look at the centimeters squared. Centimeters squared divided by centimeters, and one of them will cancel, right? It is exactly like x squared divided by x, just gives me x. So understood 1 here, and then you subtract those two exponents. So my final answer is just a singular unit of centimeters. Now, I mean, logically, that makes sense because we're just talking about a height, which is a segment length. So, no, what? I didn't even, oh my gosh. I'm going to have to redo this video. Reached the very, very end, and I boxed it in the wrong color. All right, there we go. That can. What just happened? Oh, no. Technical difficulties. A magnifying glass replaced my rectangle. Okay, so that concludes, finally, all of the problems here on parallelograms. And what we have next are going to be some triangles.